In this session, we want to talk about the coexistence of IP version 6 and IP version 4. We have looked at the structure of IP version 4 and we have looked at the structure of IP version 6. IP version 6 has been included with Windows client operating systems and servers since the release of Windows Server 2008. The use of IP version 6 is becoming more common on corporate networks and on the internet. Therefore, it is important for you to understand how this technology affects current networks and how to integrate IP version 6 into those networks. Now, the ultimate goal of IP version 6 is for IP version 4 to eventually be retired and all the systems on the network using only IP6. But this goal might take a few years to achieve. And in the meantime, we still need to have IP4 and IP6 being able to work together on the same network. So we want to talk about how we're going to have these two, IP version 6 and IP version 4, coexist on the same network. Now, the simplest and the most obvious method for transitioning from the IP4 to the IP6 is to run both the IP4 protocol and the IP6 protocol on the same node. So we have what we call dual IP stacks, where you will have a system with both IP4 protocol and IP6 protocol. When the system needs to communicate with IP4 systems, then the system uses IP4 technology. When the system needs to communicate with IP6 nodes, then the system will use the IP version 6 node technology. These types of nodes where you have dual stack technology, they have what we call IP4 compatible IP version 6 addresses. And these are addresses with the first 96 bits of the address being zeros and the last 32 bits forming a valid IP4 address. So in a dual stack IP system, every current IP4 address can be transformed to IP6 address. And here we have an example where we have the first 96 bits of the address as zeros and then the 32 bits as an IP4 address. You actually have a combination of the two. You can see here how we write it out in binary, where we have the 129.144.5238, and then you have the IP version 6 compressed form. Now, Microsoft Windows gives us some transition technologies that will help us transition from IP4 to IP6. The first one we want to look at is Teredo, and this transition technology allows both IP6 and IP4 hosts to connect with each other across the IP4 Internet. Most of us here in Barbados, we have the IP version 4 network. Our internet service provider provides IP4 network for us. So we need, if you configure a system with IP6, you still need to be able to communicate with another IP6 system on IP4 system. And Teredo is a transition technology that will help you to do that. What Teredo does or allows to happen is that the IP6 packet is encapsulated within the IP4 packet on the IP4 network. So the IP4 packet carries that IP6 packet, because the IP6 packet by itself cannot communicate on the network. There's no native IPv6 network. The native network that we have is IP4. So if you're going to communicate with an IP6, you need this transition technology to help you. The distinguishing feature of Teredo that is able to perform its function even from behind a network address translation device. What does that mean? Well, at home or in the workplace, you have private IP addresses. Private IP addresses are not routable on the internet. So what happens is your private IP address is transformed to a public IP address by a NAT device, which is usually your router that you have been given by your ISP. And the router then will convert the private IP address to public, so that your packet will be able to communicate on the internet. And then when a packet comes back into your private network, the router then will convert that public address back to the private address. So the transition technology that works with the NAT devices would be Teredo. Then we also have another transition protocol called ISATAP, Intra-site Automatic Addressing Tunnel Protocol. And this one is used only for private networks. So you can have communication between two ISATAP hosts on an IP4 network, or you can go through the router, as you see we have here in our figure. We have the ISATAP host going through the ISATAP router, and we're using the IP4 connection to do that. And then that packet is received on the IP6 network using the IP6 connection. So ISATAP then is another transition technology that allows you to communicate with an IP6 host on an IP4 network. The ISATAP address assignment gives you IP6 connectivity again between the version 6 and the version 4 host over the IP4 intranet. Again, as we said before, the communication can occur directly between the two hosts, or you can go through the router that we looked at. To recap, Teredo tunneling is a transition technology that gives full IPv6 connectivity for IPv6 capable hosts, which have no direct native connection to an IP6 network. The ISATAP address assignment technology gives us unicast IPv6 connectivity between the version 6 and the version 4 host over the IP4 intranet. IP6 packets are tunneled inside of the IP4 packets for transmission over the network. So both the ISATAP And the Teredo will take that IPv6 packet and it will encapsulate it within the IPv4 packet so that it can be taken across the network. This is the end of our session, and I want to thank you for listening.